Hello and welcome to the fourth episode of the I-Beam Trolley series. Now, today's a big one because we are going to be doing the carrier, right? The carrier is the piece that the shaft goes onto. They're welded onto the carrier and they take the rollers, and that's the main piece that takes up the loads. So without further ado, let's start the design process. But before we start drawing any lines for the carrier, we need to open up the I-Beam and the roller. Okay, now I want my carrier to be small enough to fit in this space, which is 2.6 inches and is the space of the smallest I-beam I am designing this I-beam trolley to be used with. So if it fits this one, all of the other ones which are larger, it's definitely going to fit. And then I need to have two of these rollers side by side. So I need to check this outer diameter, which is 3 inches, right? So I need to have them side by side, and it needs to have enough space to accommodate for that as well. So with that, I can now start a new part, and it's going to be a sheet metal part. So I'm going to be naming this I-Beam Trolley Carrier. Right, we're gonna start. So I'm going to start in the YZ plane. It's just that it might be easier, right? So I'm going to start, again, millimeters. Would have thought that by now I would be used to changing these to inches. But anyway, so let's do that again. Inches, okay. So for the width, I need to fit two 3-inch rollers. So I'm going to make that 6.5 inches, so I have a bit of leeway, and then for the height, I need to fit inside the 2.6 inch gap of the I-beam, so I'm just going to make that 2.5. Okay, let's make this vertical to fully define it, but the design of this first feature doesn't end there. We will add a lot of stuff on that first feature to make sure that it all fits properly in the end. Okay, so first of all, I'm going to turn this into a construction line, and then I'm going to make another couple of lines there and make these two equal. Then that means that this point is directly below the origin, which is what I want. And I will give this an initial height of 2.5 inches. So now what I'm going to do is I'm going to start sketching the various parts that are going to go onto the carrier to make sure that I have enough room when I finally assemble this. So I'll make two 3-inch circles. Sorry, I need these to be symmetric around the y-axis. So there you go. And oh, you know what? I should have made that 3 inches. I should have made that 2.5 inches, which is the diameter of the roller, right? 2.5, and I'm just going to make these two equal. Now, I know that I have a space of 2.6 inches. So if I want this entire side of the carrier to be inside that gap. You will see why in a minute. But what that means is that this circle, which is the circle that of the roller that is touching the I-beam, needs to be slightly below this construction line, which marks the end of the 2.5 inches. And how am I going to do that? Well, I can dimension this to here, and I can see the various options here. I need option number 2, and I'll say that I want a gap like this. Okay, but look at what happened now. If I dimension from this point, which is the point that of contact, up to this top line, okay, I get 2.55 inches. That's pretty close for comfort, right? I don't like that. I don't want to be cutting it that finely. So I'm just going to make that 2.4 inches. And now this flank of my carrier, first of all, is inside the free space of the I-beam, and it's got a bit of room, right? And I also want to have, I want option number 4 here. I also want to have half an inch here. 1 inch. This can now be turned into reference circles, and now I have another thing that I want to check. So I want this pointy bit in my carrier because I will have the shaft that connects the two carriers, carries the hook, carries the spacers. I will have that going through this part of the spacer of the carrier, right? And that needs to have two very specific things, right? So let me create a line here, and I want this to be reference line, and I want these to be equal to this. So this is going to be my maximum flange thickness, which I know that for this set of I-beams, I remember from my tables, the maximum is 0.4 inches, okay? So I want my shaft to be far down enough so that it clears the bottom of that I-beam. Remember that 2.6 gap we talked about was the inside gap, so we still have some flange thickness underneath that, right? So let's create a circle here. I'll make this vertical to the origin. So this is going to be a 1 inch circle because I will be using a 1 inch shaft, right? And I will also use a sketch fillet, which you will very rarely see me use. I think they only should be used on very special occasions, and I will give this a 1 inch radius as well. And then what I'm going to do is I'll make the two concentric. Okay. Now what that gives me is that you can see that in this layout sketch, right? First of all, I have a very, very simple shape, right? But I've laid out all the things that I'm going to use. Okay, so I know that the hole for my shaft is located in such a way that it'll clear the bottom of the thickest flange. I know that it gives me half an inch of meat of material. So half an inch of material here, which is, good enough to bear the load that I'm trying to bear. And it's also giving me almost 3/8 of clearance underneath my thickest flange, right? Now this dimension is going to be very, very important when we're designing the hook, right? But for now, we've drawn everything that we need to draw. We will open our Harl bar, go to the sheet metal features and create a tab. And immediately we have the basic shape of our carrier along with the hole for the shaft. And of course, this is too thin. It's because I didn't create my sheet metal parameters ahead of time. It's actually a bad habit of mine, small problem there. So if you remember, the gauge 7 mild steel sheet was 0.1793 inches. Bend radii, I want it to be equal to the thickness. I think that is a best practice instead of being half the thickness. I also think that a key factor of 0.4 is appropriate for the type of steel and the thickness that we will be using. So as soon as I click OK, you see the part adjusting to the thickness of the metal. Now, as we talked before in the previous episode, this is just 4 millimeters of steel. So is this enough to hold the 500 kilograms that we want it to hold? I'll turn into the large camera again, and I will show you this, which is a very simple ruler, and it's a pink one, which I didn't steal from my daughter for the purpose of this video. So you can see that I can bend it very, very easily, in fact, in this direction. But when I try and bend it in this direction, it's not going anywhere. It's actually hurting my fingers while still not going in. So why is it doing that? How come this very same part can resist the load so differently in these two different directions? Well, it all has to do with its moment of inertia. Now, the moment of inertia is a geometric measurement that shows how a profile, a section, is resisting the loads that you're adding to it. And in fact, for a rectangle, it is 1/12 times the base times the height along the y-axis. So if you imagine this section for a minute and imagine it's rectangular, the moment of inertia of this section is 1/12 this base times this height cubed, right? Of course, you can see that this bends very easily, but as soon as I turn it like this, now the moment of inertia is 1/12 this base, but now this large dimension, significantly larger dimension, is cubed. So this is going to be a significantly higher number than moment of inertia in this direction. So that's the whole thing. That's why you can bend the ruler very easily this way, but you cannot bend it this way. It's because as soon as you rotate that section, you get a different moment of inertia. That's the high-level explanation of it. So what has that got to do with our part here? Let's jump back in and I'll tell you. So in our part here, we're going to have two holes. We're going to have two holes here and here where the shafts are going to go. So when this takes the load, it's going to want to bend like this, right? It's going to want to bend like this. And of course, the 4.5 millimeters of steel are not enough to take that. So what can I do to fix that? Well, I can add a couple of flanges here. Okay, now look, as soon as I add these flanges, something very, very different has happened. The middle part, of course, still has the same moment of inertia, but the flanges are now located like this. And their moment of inertia is hugely, hugely larger. So this can now take significantly larger loads in that direction than it could before. Now, another thing you want to do when you're designing sheet metal pieces is the way we made this, right? It's going to have these 4 sharp corners. And because these things are cut with laser cutters or plasma cutters or whatever, these sharp corners might injure some of the workers, either the ones making the part and bending it, or the ones assembling it, and or even the user. And that's generally a bad practice. So what you want to do is either create a corner round or chamfer that corner so that it doesn't create a problem. And I think I'm just going to create a corner round of 1/4 of an inch. Fine. And again, the corner round tool in the sheet metal, you just select a face and it applies the corner round to all the corners of that face, right? That's it. And finally, we need to create the holes for our shafts, which means that we also need the shaft. Now we need to check this outer diameter, which was this number for whatever reason. Yes. Yeah, that was the 19/32 divided by 2 so that we get radius. That's what that is. Okay, we'll go back in here, right? Sketch on this surface, and I'm going to project my first sketch in, right? Create reference figures. I want to project the reference figures from that first sketch, and look, I have the position of the 2 rollers. So this is where I'm going to make holes for the shafts. Now that I think of it, I could have done that in the design of the original tap. Okay, and these are going to be 19/32, and there you go. Now I can cut that with the cut tool. Let's cut for the thickness of the part. and basically my carrier is ready. So I guess this episode was a good example of how you can lay out something with reference geometry to make sure that it assembles correctly. And it was also a good explanation of how to create sheet metal parts that are strong without necessarily being extremely thick. And as always, let's give this a color that will stand out and can guide our eyes as we're assembling it. So that's a nice part. I think we did well today. And so if you like this, hit like. If you want more, hit subscribe. Go check the rest of the episodes in this series. And in the next episode, we'll be designing the shaft. So I'll see you then.